Swayam Prabha. Digital India. Educated India.
Hello, I welcome you all in this course on refrigeration and air conditioning. Today we will discuss psychrometric chart. Psychrometric chart are very helpful in designing any air conditioning system or to understand processes involved in any air conditioning system. These charts or this chart is drawn between specific humidity. Specific humidity means kg of water per kg of dry air and dry bulb temperature. So, dry bulb temperature increases in this direction, it goes in this direction, and specific humidity increases in this direction. Now, as you know that specific humidity of any wet air is 0.622 partial pressure of vapor divided by total pressure minus partial pressure of vapor. Total pressure we can take from a barometer, but in psychrometric chart total pressure is taken as a pressure at main sea level, that is 101.325 kilopascal, that is fixed, that is P. If the vapor is saturated, then we will get specific humidity at saturation state. So, PVS by P minus PVS. PVS is nothing but partial pressure of water vapor in the saturation state. So, this pressure, the value of this pressure we can get from the steam table. Suppose outside temperature or dBT, we will assume some dBT, let us say dBT is 25%, 25 degree centigrade. If dBT is 25 degrees, here 25 degree centigrade value is not given, we will assume for 24 degree centigrade. So, suppose dBT is 24 degree centigrade, at this dry bulb temperature, the partial pressure of dBT 24 degree centigrade, the partial pressure of water vapor is going to be equal to in air in 2.986 kilopascal. Now, we have all the values, partial pressure of the water vapor, pressure, we can find the value of omega s. So, for a particular temperature 24 degree centigrade, here we can find the value of omega s, omega or omega s, that is 0.1. Similarly, suppose I want to have, suppose the dry bulb temperature is instead of 24 degree centigrade, dry bulb temperature is 10 degree centigrade. So, at 10 degree centigrade dry bulb temperature, the saturation pressure is 1.228 kilopascal. Now, again using this value and this value, we can find the value of omega s at 10 degree centigrade. Now, omega s at 10 degree centigrade will be less than the omega s at 24 degree centigrade, because if you look at the partial pressure of vapor at 10 degree centigrade, it is this, and partial pressure of water vapor at 24 degree centigrade, this is 10 degree centigrade, is 2.986. Now, here in this expression, if we further manipulate this, the 6.22 1 by P by PVS minus 1. This can be written like this also. So, the moment we increase PVS, the moment we increase PVS, or sorry, decrease, the temperature decreases, this expression will increase. The moment we increase PVS, the P by PVS will increase. So, P by PVS in case of, because P is constant, so in case of 24 degrees centigrade is less, in case of 10 degrees centigrade, this expression is more, minus 1 by this expression. So, definitely as the PVS reduces, saturation pressure of vapor reduces, specific humidity also reduces. So, this will come down at 10 degrees centigrade. Further, we can go for the 5 degrees centigrade as well. If I increase the temperature, let us say temperature is 30 degrees centigrade, the specific humidity will increase. Let us say 40 degrees centigrade, it will further increase, and we will get a line. This line, which is shown here, this line is a saturation line. Saturation line means at this line the humidity is 100%. Which humidity? Relative humidity, because relative humidity is equal to PV by PVS. Now, for these points, we have assumed that partial pressure of vapor is equal to partial pressure of saturated vapor at that particular temperature. So, phi is equal to PVS by PVS is equal to 100%. So, relative humidity at these points, so that is why it is called saturation line along this line. So, if I take this point, intermediate point, so at any intermediate point, for example, this one, let us say 28 degrees centigrade, this is going to be the humidity ratio or specific humidity at 100% relative humidity. So, this is RH 100%. Now, I want to have constant RH of 90% also. So, what we will do, we will divide these line in 10 parts, and then we will join these parts one by one on each line. So, this will give 90% RH. Now, another eighth, if eighth point is connected for all the vertical lines, that will give 80%. Now, again seventh is connected, that will give 70% relative humidity. These are constant relative humidity curves. They are shown in psychrometric chart. Now, I will show you the actual psychrometric chart here, and we will discuss the characteristic curves in psychrometric chart one by one. Now, in this psychrometric chart, if you look at this psychrometric chart, this is a dry bulb temperature line. This psychrometric chart I have taken from ASHRAE handbook 2013, and ASHRAE is American Society, stands for American Society for Heating, Refrigerating and Air Conditioning Engineers. It is a society. It has more than 50,000 members, and I am also one of the member of this society. And they publish handbooks at every year. And in 2013, they published a handbook on fundamentals, and this chart has been taken from the ASHRAE handbook on fundamentals. On x-axis, there is a dry bulb temperature. So, in this chart, the vertical lines here, they are constant dry bulb temperature lines. So, in this chart also you can see the solid vertical lines, they are constant dry bulb temperature lines. And there are horizontal lines also, and these horizontal lines are constant specific humidity lines. Now, if we are moving from this point to this point, the specific humidity is increasing from 2 grams per kg, 2 grams per kg to it is going up to 30 grams per kg. And these curves which are shown here, they are constant relative humidity curve. This is 10% relative humidity, 20%, 30%, 40%, 60% up to 100%. Now these psychrometric charts, they have constant specific volume lines also like this. Now constant specific volume lines can be drawn on this chart. I mean, how they are drawn? They are drawn, let us say we want to have a constant specific volume of 2 meter cube per kg or 1 meter cube per kg. So 1 meter cube per kg specific volume if I want to have, now PV is equal to RT relation we will use. So RT meter cube per kg, so M will not be there, and P minus PV, this is pressure of air. So RE, T is dry bulb temperature. So temperature of dry bulb multiplied by R, gas constant, divided by P minus PV. Now 1 is with us. I want to have constant volume line of 1 meter cube per kg. R we know for air, right? Let us assume one dry bulb temperature as 24 degree centigrade. 24 degree centigrade. Now R is with us, dry bulb temperature with us. P is already with us, it is given here, C level 101.325, 101.325 kilopascal. Now what is unknown here is PV. So from this equation we can find the value of PV for 1 meter cube per kg of volume. Now with the help of this PV we can find the value of specific humidity, that is 0.622 PV divided by P minus PV. Now P we have calculated from here, PV. We will put the value of PV here and we will get the value of specific humidity. So once we have the value of specific enthalpy here, we can draw lines. So let us say 24 degree centigrade. We have value of specific humidity and this will give the value of first point of constant volume line. Now again we can keep on changing the value of dry bulb temperature and we will be getting different value of, if we increase the dry bulb temperature we will be getting different values of specific humidity, and if we join all these lines we will get a constant volume line. So constant volume line, they are solid lines, they are shown here. In addition to this, constant they are solid lines, they are very inclined lines. I mean inclination is more for constant volume lines. It is starting from, I will read out the values, 0.8 it is starting, then 0.82, 0.84 and it is increasing up to 0.91. Then we have, you can see that there are certain dotted lines. These dotted lines are constant wet bulb temperature line, and close to these wet bulb temperature lines there are solid lines also. They are constant enthalpy lines. So enthalpy of water vapor mixture can be taken as enthalpy of air plus specific humidity enthalpy of vapor. Now enthalpy of air, it is Cp air T dB T dry bulb temperature, because the reference point is when the temperature is 0, this is in degree centigrade, and this enthalpy of air is taken as Cpa T dry bulb temperature, and Cpa is also assumed to be 1, so it is going to be like this. Or if you wish you can also take 1.005, this is specific heat of air, Now specific humidity is with us. Now this enthalpy of vapor, this is we are considering here saturated vapor enthalpy, because if you look at the value of saturated vapor enthalpy and enthalpy of superheated vapor, there is not much difference. So for the sake of convenience, instead of taking superheated enthalpy of superheated steam, enthalpy of saturated vapor is taken here and it is multiplied by omega. Now in this case again, for a particular dry bulb temperature, for a particular enthalpy, for enthalpy, if I want to have constant enthalpy line, we will assume particular enthalpy. Suppose enthalpy we can take here as, let us say, 80 kilojoules per kg. Assume certain dry bulb temperature and find the value of specific humidity, and same process will be repeated here and we will be getting a constant enthalpy line. Now you can see here that in the vicinity of the constant enthalpy line, there is a dotted line. This dotted line is constant wet bulb temperature line, right. Now this constant wet bulb temperature line, in some of the charts, this is chart by ASHRAE, so they are shown as two distinct lines. In some of the chart you will find both the lines are shown as one line, and then there is enthalpy deviation, some curved you will find here, curves like this you will find here, they will give you enthalpy deviation. Now in this chart, because these two lines are given distinctly shown, and you can see that the difference between these two lines is increasing. Or if I choose constant wet bulb temperature line, constant wet bulb temperature line, so initially it has less enthalpy, but when it is moving in this direction, the enthalpy has slightly increased. Along the constant wet bulb temperature line, the enthalpy is not constant, it has slightly increased. Why it has increased? It has increased because more water vapor is added during this process, and enthalpy of water vapor is also accounted while calculating enthalpy of this enthalpy of the air. So that is why the inclination of this, so inclination of this line is a slightly more than the inclination of constant enthalpy line, right. Now in this chart there are certain marks also on the right hand side, and there is a half circle you can see here, and it has also certain numbers. So these marks and these numbers will be used while doing the load calculations in an air conditioning system. At the center of this chart there is a small circle. Now this circle indicates the ideal condition. Now here ideal condition is 24 degrees centigrade temperature and 50% RH, but in most of the books you will find that ideal condition is 25 degrees centigrade temperature and 50% RH. Reason being, it is a statistical value, the temperature at which the most of the people feel comfortable is 76 Fahrenheit. Now if you convert this 76 Fahrenheit to degree centigrade, it turns out to be 76 minus 32 divided by 180 is equal to degree centigrade divided by 100. So 76 minus 32 into 5 divided by 9. So it will give 24.44 degrees centigrade. So it is rounded off to near integer here, and it is taken as 24 degrees centigrade, but we take 25 degrees centigrade because in India most of the case we are doing cooling. So we do not recommend to be cooled up to 24 degrees centigrade. We said if you cool up to 25 degrees centigrade, the ideal state is attained. This can save some energy also and at 25% degree centigrade temperature, most of the people in our country, they feel comfortable. Now after this, we will take some examples. I think that will make things more clearer here. Now atmospheric air at 25 degree centigrade, dry bulb temperature with a specific humidity of 10 grams per kg of air, find relative humidity. Now simply, otherwise you may have to do elaborate calculations in this case, but here it is very simple to do. 10 grams relative humidity, constant relative humidity line is this one, and dry bulb temperature 25 degree is this one. So where it is cutting the 10, it is here. So it is between 40 to, it is around 47%. So immediately looking at this chart without doing any calculations, you can find the relative humidity. Dew point temperature. Now dew point temperature is a temperature where dry bulb, wet bulb and wet bulb temperature are same. So if I want to have in a psychrometric chart dew point temperature, I will locate it on saturation line. So at the saturation line, the dry bulb temperature, wet bulb temperature and dry bulb temperature and wet bulb temperature are same, and this is known as dew point temperature. So here if now I have located this state of vapor here, now if I move in a horizontal direction, then I will get a dew point temperature which is approximately, which is actually 14 degrees centigrade. So from the state of the air, if you draw a horizontal line, if you follow horizontal line and where it is cutting the saturation line, that is the dew point temperature of air. Partial pressure of vapor. So partial pressure of vapor, again you have the specific heat and you will have to use that equation, omega is equal to, or we can use relative humidity is equal to partial pressure of vapor, partial vapor at saturation state. So at 25 degree centigrade, we will take the partial pressure of the vapor from this chart and we will put that value here. Relative humidity is already with us, we can find the partial pressure of vapor. So in this next one, atmospheric air at 101 kilopascal has a dry bulb temperature 35. So dry bulb temperature is 35 and wet bulb temperature is 25. So we will take a 25 degree centigrade wet bulb temperature line which will lie between this to this. So somewhere here, this is 25 wet bulb temperature line and it will 25 this much. So the state is here and from this state we can find number of values, for example specific humidity on going into the right hand side, then dew point will go to the left hand side, dew point will be around 22 degrees centigrade. Relative humidity is, we can take from here, it is around 45%. Enthalpy of mixture, we can take enthalpy of mixture here as 70 and 70, 75 and this is 70 and this is 80. So 72, 74, 76, 76.5 and pressure of water vapor, again we can use the same formula PV by PVS. So these psychrometric charts are very helpful in order to find the properties of moist air. In the next lecture, we will take up the psychrometric processes. That is all for today. Thank you.